A steel beam weighing several tons is swinging through open air, 300 feet above a Manhattan street. One man is guiding it with his hands. He has no harness, no net, nothing between him and the ground below except judgment and years of practice. Before cranes could be operated from the ground, before any of this was routine, entire cities had to learn from scratch how to build into the sky, and every connection holding those buildings together depended on a process that had to be completed in under 20 seconds. In the 1880s, American cities were running out of ground. The only direction left was up. But traditional walls had a hard limit: build taller, and the base had to grow thicker. At some point, you were consuming the very space you were trying to sell. Then came Bessemer's process: blast air through molten iron, strip the impurities, produce steel at industrial scale. Now, buildings could rise on a skeleton. The walls carried nothing, the steel carried everything, but steel alone doesn't build a skyscraper. Someone still had to connect it. So how did you actually get it to hold together, hundreds of feet in the air, without the welding technology we rely on today? The men who answered that question were called iron workers. They did not learn the trade in classrooms. They learned it by standing beside experienced hands, watching the angle, listening to the sounds, developing a sense for weight and balance that could not be written down. Among the most skilled were Mohawk iron workers from the Kanawaka community near Montreal, who had been working high steel since 1886. By the early 20th century, they were present on nearly every major structural project in New York City. They spoke their own languages on the job. They trusted each other absolutely. In their community in Brooklyn, a sign above a local bar read, "The greatest iron workers in the world pass through these doors." That trust was not sentimental. At those heights, it was structural. Before a single beam was lifted, the logistics had to be solved on the ground. Steel I-beams were not stored at construction sites. Cities like New York had no room for stockpiles. Every beam was fabricated off-site, numbered according to its position in the structure, and delivered in the exact sequence it would be installed. If a shipment arrived out of order, or didn't arrive at all, work stopped. The entire site, with hundreds of men, stood idle. Once beams arrived, derrick cranes, powered first by steam engines, later by internal combustion, hoisted them floor by floor. The ironworkers directed each lift using hand signals. No radio, no intercom. A vocabulary of gestures developed over years, communicated weight, direction and timing across distances where voices couldn't carry. The beams had to land within a few inches of their intended position. The men guiding them used their bodies to slow and steer the load. Once a beam was in position, it had to be connected, immediately and permanently. Arc welding existed by the late 19th century. Engineers rejected it. Steel quality varied from batch to batch, and there was no reliable method to inspect a weld from the inside. A weld that looked sound on the surface could contain hidden fractures. At these heights, under these loads, hidden fractures were not acceptable. The answer was riveting. And it required 4 men working in precise, uninterrupted sequence. The heater pulled a rivet from a portable forge, glowing orange, nearly white, and threw it through the air to a catcher standing on the beam above. The catcher caught it in a tin can. The bucker-up pressed it into the pre-drilled hole. The driver set the pneumatic hammer and drove the other end flat against the steel. If the alignment was wrong, if the rivet cooled before it was fully seated, the connection was compromised. The entire sequence had to be completed in under 20 seconds, because as the rivet cooled, it contracted, pulling the steel plates tightly together in a grip that could not be undone. This was not a process that could be rushed or improvised or partially completed. Every rivet was either right or it wasn't. There is a moment, described in contemporary accounts from the 1890s, when a riveting gang finds its rhythm. The forge glows, the toss is clean, the catch is immediate. The hammer begins before the echo of the catch has finished. Short, precise, bone-jarring impacts. Then silence. Then the next rivet is already in the fire. On a productive floor, multiple gangs worked simultaneously, each one feeding off the other's rhythm. The sound carried for blocks. Passers-by stopped to look up. The New York Times in 1931 called it the best open-air show in town. Connecting the steel was only half the problem. Steel is not fireproof. Under extreme heat, the kind generated in a building fire, structural steel loses its strength rapidly. An unprotected steel frame can collapse in under an hour. After the Chicago fire of 1871 destroyed iron structures that architects had believed to be fireproof, engineers developed a solution. Terracotta tiles, hand-fitted around every beam and column. Each tile was shaped to the specific section it covered. Workers followed directly behind the ironworkers, fitting and mortaring tiles to every exposed surface. By 1895, according to Britannica's Technical History of Construction, the mature high-rise formula had been established: rolled steel I-beams with riveted connections, clay tile fireproofing, and caisson foundations. Not one element of that system could be omitted. Each depended on the others. By the early 20th century, ironworking had become one of the most documented and romanticized trades in American industrial life. Photographer Lewis Hine, commissioned to document the construction of the Empire State Building in 1930, suspended himself in a basket 1,000 feet above Fifth Avenue to photograph the men at work. His photographs show something that safety regulations would eventually make impossible: workers sitting on open beams eating lunch with nothing below them but 800 feet of air. The knowledge those men carried was not written anywhere. It was passed through proximity, repetition, and consequence. Riveting dominated skyscraper construction for nearly 60 years. By the 1950s, improvements in steel manufacturing had standardized quality sufficiently that welding could finally be trusted. Inspection technology advanced. The four-man gang, the heater, the catcher, the bucker-up, the driver, was phased out. Not because riveting had failed, because the conditions that made welding unreliable had finally been resolved. The men who had carried that system were not replaced by better workers. They were replaced by better materials. The first American skyscrapers were not built on certainty. There was no proven method, no established safety code, no precedent for what it meant to guide steel beams into position 300 feet in the air. Long before building codes formalized what safety looked like, durability depended on judgment, on rhythm, on the steady decision, made daily, to show up and do the work exactly right. These systems shaped the skylines we now take for granted. If you'd like to see more of them documented, consider subscribing, and tell us, which forgotten craft or construction method should we uncover next?